This video will show you how to design planetary gears using the Planetary design feature. The window shows that it is possible to design both simple and compound planetary gear systems. First, let us make an example of a simple planetary gear system. We will use the sun gear as the input and the carrier as the output, with a desired speed ratio of 4. In this case, the ring gear is fixed. We will use the minimum and maximum numbers of teeth that are already filled in. When we run the calculation, we can see that there are a total of 7 results for these specifications. We can select any one of them, and the software assembles the desired planetary gear system. The selected numbers of teeth are applied, together with the desired speed ratio. Notice that the carriers have equal angles. We will later see a case in which this does not happen. When we click on Planetary Design again, the results from the last project appear once more, allowing us to select another result if desired. Going back, we can see in Assembly Constraints that the option Carriers with Equal Angles is selected. Let us uncheck it and see how the results change. Now there are 19 possible results. When we select one of them, we can see that the carrier angles are no longer equal. Even though this may be difficult to visualize, different angles can cause vibration and imbalance and should be avoided in a planetary gear design. Let us start a new project. It is possible to place planets in series in a planetary gear design. When we select one of the results, the software assembles the chosen design. Notice that the carrier is straight. Although this is an acceptable result, it may lead to a very wide ring gear. Notice that a new option appears in Assembly Constraints called Straight Carrier Only. Let us uncheck it and see how the results change. For this option, there are many more possibilities to be studied, so the calculation takes longer to finish. But do not worry, I have a potato computer, so it is slower. Now there are more than 2,000 results. The software shows up to 100 results per page. Let us select one of them. Notice how the design is much more compact. The angles of the bent carrier have different values, but their spacing remains 120 degrees between them. Now let us make a compound planetary gear design. There are design options for 2-stage and 3-stage planetary gear systems. Be careful when trying to make 3-stage designs because they can be very time-consuming due to the thousands and thousands of possible results. Let us make a 2-stage design we will use the default input and output. For this compound planetary gear design, 3 boundary conditions are required, with the software automatically setting the input speed to 10 RPM. The boundary conditions include 1 fixed component and 2 couplings between the planetary gear systems. These boundary conditions can be modified. Notice that in assembly constraints there is a new option called Force Coaxial Planets. This option adjusts the planetary modules, or diametral pitches, so that the distance from the system center to the planet axes is identical in all stages, allowing physical coupling and rendering as a single part. For this design, there are more than 2,000 results. Let us choose one of them. It can be seen that the planets are coupled as a single part, even though their numbers of teeth are different. When checking the gear data, we can see that the software modified the module of the first planetary stage in order to force the planets to become coaxial.